Hi guys, welcome back to Math with OG. If you are yet to hit the subscribe button, kindly press the subscribe button. It will cost you absolutely nothing. And also like this video so that it can reach other people. Now we'll be looking at what problems in sets. But we're focusing on two subsets. Now next video we'll move on to three subsets. So how do we tackle questions under what problems in sets? Now I have a formula on the board. If I give you a universal set with two subsets, let's say a subset A and a subset B. The cardinality of the universal set, that means the total number of elements in the universal set, is equal to the cardinality of subset A plus the cardinality of subset B minus the cardinality of what is common to A and B plus the cardinality of the complement of A intersect B. Sorry, cardinality of A union B. So let me correct that. This should be A union B. That means everything outside A and B. So it is A plus B minus what is common to A and B plus what you have outside A and B. So okay, this remains the same. Now what if the formula is reduced? We are now looking at just A union B. We are not dealing with the universal set. So what is the cardinality of just A union B? A union B on its own is equal to the cardinality of A plus the cardinality of B minus cardinality of what is common to A and B. So everything here, NA plus NB minus NA intersect B is simply NA union B. So this is NA union B plus NA union B complement. Altogether, that will give us the universal set. Now, the other way of solving it is simply drawing the Venn diagram on your own and calling what is common to A and B an unknown, let's say X, then use that reference X to get what is in A only and what is in B only. So as we play with questions, you understand all what I'm talking about, because I don't work with these formulas. I usually draw the Venn diagrams, impute values, and add them up to get the universal set. Now let's look at this question so that you understand all what I'm saying. First question here. In a class of 30 students, 25 like football and 15 like wrestling. Every pupil like at least one of these sports. That means the 30 students in that class, all the people there either like wrestling or football or both. That means there's no student in that class that do not like either football or wrestling. So that's what they are saying here. Every people like at least one of these sports. How many students like both sports? How many students like both sports? So if we are to work with our formula, how many students like both sports? We will not be dealing with this part here. So let me circle it with another color entirely. So we'll not be dealing with this because this is for those who don't like football or wrestling. And we don't have any students in the class that do not like football or wrestling. Everybody like at least one of the sports. So I can simply say A union B, or we can use the universal set without including this, or we can just work with A union B. So I can say N A union B is equal to NA plus NB minus NA intersect B. So let our A be football and let our B be wrestling. So how many of them total? There are 30 total. Football, 25 people like football. How many like wrestling? 15 like wrestling. Minus what is those that like both sports. So let's call those that like both sports X. So this is 30 is equal to 25 plus 15. That should give us 40 minus X. Now the next thing is to collect like terms. So let's move our 40 to the other side, or let's subtract 40 from both sides. If I subtract 40 from both sides, here should be minus 10 is equal to minus X. Now I can divide both sides by minus 1 or multiply both sides by minus 1. So X will be equal to 10. So I can say 25 students like football, 15 students like wrestling. However, 10 students like both football and wrestling. 25 like football, 15 like wrestling. However, 10 like both football and wrestling. Like I said, you can solve using your Venn diagram. So if I call this guy here football, and call this guy here wrestling. I don't know the number of students that like both sports, so I'll say let the number of students be X. So this is for those that like both sports. So if X students like both sports and this X student is part of those that like football, similarly this X student is part of those that like wrestling. So in total, I have 25 people liking football, 25 people liking football, but X of them also like wrestling. So how many of them will like football only? Is simply 25 minus the number of people that like football and wrestling. So 25 minus X is the number of people that like football only, but 25 in total is the number that like football. So if I add 25 minus X to X, if I add them up, this should give me 25, which is the total people that like football. Similarly for wrestling, 15 people like wrestling, but X of them like football and wrestling. So how many like wrestling only? Is simply 15 minus X. Now that we've gotten that, and we don't have any students here that do not like either football or wrestling, so that place is empty. So what is the universal set? From the question, the universal set is equal to 30 students. So since the universal set is 30 students, it means the summation of these three guys should give us 30. So let's add up. I'll write here 25 minus x plus x plus 15 minus x is equal to 30. 25 plus 15 is 40. Minus x plus x is 0. 0 minus x is minus x is equal to 30. So x here is simply 40 minus 30. So x is what? 10. So I collected like terms. That means I added x to both sides. So x will leave here and move to the other side. And I subtracted 30 from both sides. 30 will leave here and come here. 40 minus 30, 10. X to the other side will be x. So we have 10 students. And as you can see, we're having exactly the same answer. So that is how you solve using the Venn diagram. That means we are not making use of the formula. So you can always represent it, and after a presentation, it is very easy to solve without making use of the formula. Now let's move on to the second question. A and B are two sets. The number of elements in A in your B is 49. The number of in A is 22 and the number in B is 34. How many elements are in A intercept B? So we are given the cardinality of the union of both sets, given the cardinality of one of the sets, given the cardinality of the other sets. Now let's find the cardinality common to both sets. So in this case, let's just make use of the formula, and that is pretty straightforward. So number of elements in A in your B is 49. Look at the formula here. So this is 49 is equal to A, number in A, we are not told A only, we are told A. So number in A is 22 plus number in B is 34 minus what is common to both of them. Let's call it X. So this is 49 is equal to 56 minus X. So move minus X to the other side, or we say add X to both sides. This side will be X. Subtract 49 from both sides. This will be 56 minus 49. So X is equal to 7. So we have 7 to be common to both of them. Let's add this up, subtract 49. The answer should give you 7. Now over to the last question. There are 50 people in a meeting. 35 of them speak Bini and 30 Urhobo. 10 speak neither. So we have 10 students that don't speak either Bini or Urhobo. So I'm going to use this Venn diagram to solve this question. Draw a Venn diagram and find the number of people who speak both languages and those that speak Bini but not Urhobo. Okay, let me just draw a new Venn diagram. 50 people in a meeting, so that should represent my universal set. U is equal to 50. Let this be for Bini and let this be for Urhobo. So we are told that 35 of them speak Bini, 30 speak Urhobo. How many speak both? We don't know, so let's call it X. So if 35 speak Bini, it means that 35 minus X speak Bini only. And 30 speak Urhobo, it means 30 minus X speak Urhobo only. 10 speak neither, so you can see them here. 10 people, and not sabi speak Bini, and not sabi speak Urhobo. So that's where you find them. Now draw a Venn diagram and find the number of people who speak both languages. Both languages is x, so we are simply looking for x. So let's solve for x. All right, here 35 minus x, this guy, plus this guy is x, plus 30 minus x plus 10 is equal to 50. 35 plus 30, that should be 65, plus 10, that should give us 75. Minus x plus x is 0, 0 minus x is minus x is equal to 50. So in this case, I'll say that my x is equal to 75 minus 50. So my x here is equal to 25. So I have 25 people that speak both languages. Inside the 35 that speak Benin, 25 of them speak both languages. Inside the 30 that speak Yoruba, 25 of them speak both languages. So the big question, Benin but not Yoruba, that means Benin only. So it can also be in the form of Benin intersect Yoruba complement. So this is also Benin only. The cardinality of Benin intersect Yoruba complement. So those that speak Benin but not Yoruba, as you can see here, it's simply 35 minus x. Benin but not Yoruba, B part is simply 35 minus x. So that will give us 35 minus 25. So the answer is 10. So 35 of them speak Benin, but only 10 of them speak Benin but not Yoruba. But 25 speak Benin and Yoruba. So I can say those that speak Yoruba but not Benin is 30 minus 25, and that will give me 5 people. So 5 people speak Yoruba. Sorry, those that speak Yoruba but not Benin is 30 minus 25, and that will give us 5 people. 5 people speak Yoruba only, 10 people speak Benin only, and 25 speak both Benin and Yoruba. So that is how you tackle questions on two subsets. What problems in sets focusing on two subsets. So these are the type of questions. Though some other questions can come different shapes, in different shapes, but they follow the same principle. So if you understand this, I believe you can tackle any questions under two subsets. Now, subsequently, like I've told you guys before, when we are done with more topics, major topics, I'll start answering questions based on your Jamb past question, Waec past question, your Neco past question. But for now, what we are doing is to simply explain everything you need to know in these topics. Then when we are done, we'll start playing the questions, and you see that everything we are doing is very straightforward, and the exams you are preparing for, they are actually very easy. So if you found this video to be helpful, use the like button, use the subscribe button, and don't hesitate to comment if there's any correction you wish to make, and if there's any question you wish to ask. Don't also forget to share with your friends that you know we also need this video. Thanks for watching. See you guys in our next video.